Problem, we are asked to complete the sentence with the word always, sometimes, or never. In a perfect square, the vertex is H0. Let's just look at the model of a perfect square. We'll start by filling in an x by x square. So the area here is x squared. Now let's go ahead and fill in some x bars. So we'll do one on each side, one at a time. So we now have one x bar. Let's go ahead and do another one. Let's go ahead and do one more. Looks like we have room for another one. And let's go ahead and just do this last set of x bars. So here we have our x bars. Let me highlight our units in purple. There we go. Okay, so how many x bars did we add? 1, 2, 3, 4, 5, 6. So that looks like x plus 6. And then over here, 1, 2, 3, 4, 5, 6. X plus 6. So our dimensions of this square, if we do side length squared, is x plus 6 squared. Now that 6 was kind of arbitrary. It's just what we felt like we could fit in this particular square. But as I make the square bigger, that number of 6 could be bigger or it could be smaller. As I make the square smaller, it could also be negative if my x bars were a negative x instead of a positive x. Regardless of the amount that I'm adding or subtracting, I have to do it on the same side. So my equation in vertex form will always have this form, and it'll always have to be plus 0 out here because we cannot have any extra blocks and we can't remove blocks. So if we want a perfect square, we're going to have a k value of 0. So our equation, x plus 6 squared, is really x plus h squared. So this has the vertex of h comma 0, because we could do x minus h squared just the same as we did x plus h, and our vertex is still h0. Okay, so in a perfect square, the vertex is always h0, where h is this amount that we're adding or subtracting on each side. And k must be 0 because we can't add any extra blocks or take away any of those unit blocks. So it will always be h0 for a perfect square. Now, what does this mean as far as the graph goes? Well, that's pretty useful. So this means that our vertex must be on the x-axis. So we could have this as a perfect square, or we could have this as a perfect square. So it can open down, and it would be h0, where the vertex is on the axis.